Hey everybody, this is Chapter 4, Section 6. Title is Formalizing Relations and Functions. Starts on page 268. We're just going to try to fly through this. I hope it doesn't take too long. A couple of definitions. First of all, a relation is just a set of ordered pairs. So if you put ordered pairs together, you get what's called a relation. We've used some of those before, but we've never called it a relation before. When the directions say something about a relation, it just means a set of ordered pairs. Domain, we mentioned this once before. Domain is the list of all of the x values, and they're written in order from lowest to highest. Range is the list of all y values in the problem, also written in order. A mapping diagram has the domain and the range in separate lists, and there's arrows going between each ordered pair, and we'll do an example of that in a second. A relation would be called a function if each x value points to its own y value. We mentioned whether or not something is a function earlier in the chapter. This is the same idea. If you draw lines from x's to y's, as long as you have each x going to its own y, then that means that it's a function. So, first example problem. Identify domain and range of each relation. Represent the relation with a mapping diagram. And that should say, is the relation a function? So first, we have to list the domain and range. We're going to end up with a mapping diagram too, so I'm just going to write out things in a certain order. So we're going to have domain here. We're going to have range over here. So my domain is my list of all my x's. So I've got 4.2 from there and there. Okay, it repeats, but I only read it down once. I've got a 5, and I've got a 7. Okay, those are all my x's, so I listed my domain. Now I'm going to list my range, so all of my y's. My lowest y is a 0. My next lowest is a 1.5. My next lowest is a 2.2. My next lowest is a 4.8. Okay, I listed out all my y values, that's my range. Now I draw an arrow from all of my domains to the range that goes with it. So 4.2 goes with 1.5 from this ordered pair. And 4.2 also goes to 0 from this ordered pair. 5 goes with 2.2. And 7 goes with 4.8. Okay? That is a mapping diagram. Arrows going from each domain to the range that goes with it. Last, it says, is the relation a function? Is this a function? Does each domain go to one range? No. This domain right here has 2 arrows coming from it, which means not a function. Okay? We'll do the same thing with B. Put my domains. Okay, my lowest number, -2, then -1, then 4, then 7. Those are all my x's. My range are all my y's. I've got a -7, a -4, a 1 from there, and then a 2. Okay, I listed my domains and my range. Now I need a mapping diagram. -2 goes with +2. -1 goes with 1. 4 and -4 to go together. And 7 and -7 go together. Does each domain have one arrow coming from it? Yes, which means it is a function. Practice problem doing the exact same thing. Another way to decide if a relation is a function is to look at the graph instead of the ordered pairs. You can look at the graph using the vertical line test. Vertical line means straight up and down. If there's any way that you can put a vertical line through the graph more than once, then it's not a function. Okay? If we look at this first one over here, we'll call it A. Is there any place where I can put a line straight up and down that will go through more than one spot? Well, since the dots are in red, I'm going to put it in blue. There's a vertical line straight up and down. It goes through two of the dots, so it's not a function. We'll call this B. Is there a vertical line I can draw that hits that graph more than once? Sure, there's actually a whole bunch of them. There's one, hits the graph two different places. There's one, hits the graph two different places. Okay, I could draw a whole bunch of lines that'll do that. Remember, lines have to be straight up and down in order for this to work. So this one, not a function. Next one, we'll call this letter C. Is there any place I can draw a line straight up and down that'll hit that more than once? Well, if I draw a line there, only hits it once. There, only hits it once. There, only hits it once. Any place I draw a straight vertical line, it only hits it once. The conclusion you make, it is a function. I spelled that wrong. Okay, over here for letter D, any place I draw a vertical line, I only hit my graph once, so it is a function. Couple of practice problems asking you to do the same thing. So far, our functions in this chapter have had x and y in them. My typing isn't very good today. We've seen things like y equals negative 3x plus 1. Okay? You can also write the same equation using what's called function notation. Okay? We don't use this a whole lot in algebra. I know it shows up in the ECA, which is why I mention it. But you use this a lot in geometry, algebra 2, pre-calc, stuff like that. So this comes back a lot. The basic idea, you're going to take the y out and you're going to replace it with f of x. Okay, this f and this x thing. All I did was I took the y out and I put that f in the parentheses x in its place. When you read that out loud, it says f of x. What that means is if you plug x into the function, this is what you get for an answer. Okay, so if I plug something in for x here, that means I also have to plug it in over there. F here, it's not a variable, it's actually the name of the function. You can use other letters to name functions as well, like G and H. We'll show some of those in a minute. If you plug a number into f of x, like if you plug 7 into your function, this means plug that number into the problem and get the answer. So here's your example. What is f of 2 for the function f of x equals 4x plus 1? This 2 right here means anytime I see an x, plug 2 in for it. So I took this line and I brought it down here. Instead of x, I wrote a 2. Instead of x, I wrote a 2. And now I just have to do the math. 4 times 2 is 8. 8 plus 1 gives me 9. Okay? This means that when I plug in 2, my answer is 9. Okay? In this case, 2 is like the x value. Y is like, 9 is like a y value. So if I had to turn this into an ordered pair, it would be 2, 9. Okay? Function notation is just a different way of writing it. You still plug in numbers, get answers just like you have been. You can also use function notation for word problems. Most of the words in these problems are useless. You care about the equation and the number you're supposed to plug into it. You care about the equation and the number that you're supposed to plug into it. Give those a shot. Another type of problem they do in this section. If the problem gives you a domain, remember, domain means the x values, the numbers that you plug in. Take each value, plug it into the function one at a time to find the range. Okay? So, the domain of this function, this time we called it g, the function is 4x minus 12, and the domain that they gave us is 1, 3, 5, and 7. it asks what is the range. Remember, range means answers. Domain means stuff that you plug in. So first, I take 1, which is the first number in my domain, and I plug it into my equation. So I plug 1 in for x and x. 4 times 1 is 4. 4 minus 12 gives me negative 8. So when I plugged in a 1, I got an answer of negative 8. Next, I go down the list. I plugged in the 1. Now I'm going to plug in the 3. Plug in 3. 4 times 3 is 12. Minus 12 gives me an answer of 0. So when I plug in 3, I get 0. Done with that one. Now I do 5. Same thing. Plug in 5. Get an answer of 8. Now I do the same thing with 7. Plug in 7. Get an answer. Whoops. Plug in 7. Get an answer of 16. Now remember, it wanted the range, which is my list of answers. My answers, negative 8, 0, 8, and 16. Practice problem. It gives you the function 1/2 x, and it says the domain is those 5 numbers. So you're going to plug in these, and it's asking you for the list of answers. Okay. One more type of problem here. When the problem asks for reasonable domain and range, it's asking you to figure out what numbers would make sense in the problem. And I've got an example here. Lorena has 4 rolls of ribbon to make party favors. Each roll can be used to make up to 30 favors. The function represents the number of favors, which is f of r, that can be made if you have r rolls. What is a reasonable domain and range of the function? Now, when it says reasonable, what makes common sense? R stands for rolls. How many rolls of ribbon can Lorena use? Well, she can't use a negative number of ribbon. That doesn't make sense. She only has 4, so she can't possibly use 5 or 6 or 7 rolls. So the only things that make sense are between 0 and 4. Now, could she use like 2.5 or 2.7? Sure. Fractions and decimals would make sense in this problem. Okay, so that would be, remember, that's the word continuous if fractions and decimals make sense. So the way that we would write it, we would put r for rolls in between 0 and 4. And the reason why we use the equal parts is because it would make sense to use 0, or it could make sense to use 4. Okay? F of r stands for the number of favors that she can make. Can't be negative. It wouldn't make sense to make a negative number of party favors. If she uses all of her rolls, that would be a total of 120 favors. Because if you plug in 4, you get 30 times 4, which is 120. So the highest number that she can make is 120. The lowest number she can make is 0, because she can't be negative. Now, in this one, it wouldn't really make sense to make half of a party favor. Somebody would be disappointed. So fractions and decimals wouldn't really make sense here. So we write it like this. F of r, that stands for the number of party favors. It's between 0 and 120, and that would be my range. Domain, that's the numbers I'm plugging in. Range is the number I'm getting out for my answers. So when it says a reasonable domain and range, this is what it's asking you for. What numbers would make sense to plug into the problem, and what numbers would make sense to get out of the problem. Last example here, or last practice problem, find a reasonable domain and range for that. Once again, a spot for any questions or comments.